Hi y'all, welcome to Algebra 2. This is Unit 2, Homework 1. So let's start. Question 1 is simply asking you, like, what is the process of rewriting a polynomial as a product of its factor? What do you call that? Well, it's just simply saying this, okay? To convert from standard to a factor, you would use like a process called factoring. Factoring basically writes your equation as a product of factors, right? That's what it does. X-intercepts are product means multiplication, right? Like this is a product of factors, so your factors are x minus 2 and x minus 3 here. That's what basically it is, okay? X-intercepts are also known as zeros and roots. So if someone asks you, hey, what are the zeros for this? They're simply asking you for the x-intercepts. Or if they even say, what are the roots for this? Again, they're asking you for the x-intercepts. So yeah, that's it. This is asking you to multiply. How would you multiply this? You would take this x, right, and you would times it with x minus 3. You would take this negative 2 and times it with x minus 3 as well, right? And then you can distribute this x, you get x squared minus 3x. You distribute this negative 2, you get negative 2x plus 6, right? Combine the like terms, you get x squared minus 5x plus 6. Perfect. Now they're asking you to factor this. And the reason why I chose this as a factor is because I want to talk about like going backwards. You see, when you talk about factoring, we always do a times c and like b. You're trying to find factors of a times c that add up to b. But why? Why that specifically? You see, back in 14th or 15th century was it? I kind of was like figuring out like how can I factor, right? Back in 15th century, and it took me like 20 odd days or something, 25 days I think it was. That's a long time, but that's okay. But I was trying to figure it out, right? So I sat down and I was like, well, if I know how to go from here to here, I know how to go from here to here as well. All I gotta do is just back step, right? Take the steps but backwards, if that makes sense. Well, looking here, I'm given this. If I want to get this, I want to take the step back. Just by looking at it, what is the difference between these two? The difference is this right here. I need to figure out what are these two numbers for this specific equation. I know it's this negative 3 and negative 2, but like, how can I get that? My question to you is this, and I think that was where my genius comes in, is where this negative 3 and negative 2 I realized was, it's this, when I add them I get negative 5, I get the middle term, right? I get the middle term, and that's how it went. You were simplifying it, right? But the one thing I noticed was that the product negative 3 times negative 2 is 6, which is also like 1 times 6, right? I think that's like the really interesting thing about my genius part was that I noticed that it's negative 3 times negative 2 is positive 6, which is why we do this. We are trying to find factors of a times c that adds up to b, because look, in here case a times c is positive 6 and b is negative 5. So what are factors of 6 that gets to negative 5? It's negative 2, negative 3. Oh, you see, negative 2 and negative 3. Interesting. Perfect. How do we use that information to do this? Well, I already know, I'm going to break this down, this negative 5 down into negative 3 and negative 2. How? You're given x squared minus 5x plus 6. Break it down into 2. X squared minus 3x minus 2x plus 6. You see how it's the exact same step, just backwards. Now, how did I get this from, like, right? See here I distributed, right? The opposite of distribution is factoring. I'm gonna factor these two terms. I'm gonna factor them, okay? If I factor here, I'm gonna factor out an x. I'm left with x minus 3. Here, I'm gonna factor out a negative 2. I'm left with x minus 3 as well. You see, it's exact same thing. And then factor again. Factor this 2 as I'm going to factor this 2, okay? What do they both have in common? It's this x minus 3. Well, if I take out an x minus 3, right, I'm taking out this box, I'm taking out this box, right? I factor that out. I'm left with x and negative 2. Combine them. Right? There you go, you factored. Perfect. So what pattern do you notice between multiplying factors and doing the process of factoring? Well, basically, factoring is backwards of multiplying factors. Cool. Moving on. This is like some things. Alright, so now that you have this, you have to find the x-intercepts, y-intercepts, and the vertex point. To find the y-intercepts, all you do is plug in 0 for x. If you plug in 0 for x, here, your y-intercepts is 6. Y-intercept is 6. To find the x-intercepts, you will have to set it equal to 0. Set f function equal to 0, right? And then you will have to factor. Okay? So to factor, you do a times c, 2 times 6, which is 12, b is negative 8. What are factors of 12 that gets you negative 8? Are there factors of 12 that gets you negative 8? There are, 6 and 2, right? Can I not do negative 2, negative 6? Negative 2 times negative 6 is positive 12. Negative 2 plus negative 6 is negative 8. So, I have this information, I'm going to break it down. Negative 2x minus 6x plus 6. Right? This 2 and this 2, what do they have in common? These two have a 2x in common, you're left with x minus 1. These two have negative 6 in common, you're left with x minus 1 as well. So, your factors are 2x minus 6, x minus 1 equals 0, set them equal to 0, you get 2x minus 6 equals 0, x minus 1 equals 0, so x equals 3 or x equals 1. Those are your x-intercepts, right? As I'm talking about that, like as I'm doing that, I'm noticing one thing where to find the, well, I know my x-intercepts, right? My x-intercepts are 3 and my x-intercepts are 1. That's the point of doing this entire method, was to figure out my x-intercepts. Sometimes what happens is that they will already give you in factored form, so all you do is set them equal to 0, but sometimes they'll give you standard form and you will have to figure out the factors and then set them equal to 0 to figure out the x-intercepts. Or you could use a quadratic formula. I would not use quadratic formula if you can do factoring, because just like there's so many steps in quadratic formula that it's easier to make mistakes, and we will talk about that later as well. But for now, let's continue doing this. So you got your x-intercepts. X-intercepts are 3 and x-intercept is 1. How do you figure out the vertex point? One of the definitions that we talked about in class is this: x value of the vertex point is in between the two x-intercepts. What am I saying by that? If I'm talking about vertex point, I'm talking about x and y, right? It's a point. The x value is in between the x-intercepts. So 3 and 1, what is between 3 and 1? Well, it's 2, right? And what is the y value of it? Well, you're going to plug it in, right? So when you plug it in, you get 2 square, which is 4. 4 times 2 is 8, so that's 8. Minus 2 times 8 is 16. Plus 6. So what is that? 8 minus 16 is negative 8. Negative 8 plus 6 is negative 2. So it's 2 comma negative 2. You found the x-intercepts. X-intercepts are 3. X-intercepts are 1. Y-intercepts is 0 comma 6. And vertex point is 2 comma negative 2. You did everything. Perfect. Now for this one, they already given you factor form, right? So all you do is set each factor equal to 0. You get x minus 2 equals 0. X minus 4 equals 0, so x equals 2, x equals 4, and that's your x-intercepts. To find the y-intercept, you plug in 0 for x, right? And you get -2, -4, so it's +8, so it's 16. So y-intercept is 16, just plug in 0 for x, okay? Alrighty. To find the vertex point, all you do again is you're given the x-intercepts 2 and 4. What is in between? It's 3. Plug in 3. 3 minus 2 is 1. 3 minus 4 is -1. And that's -2. That's it, right? Here we do the same thing again. X-intercepts is x minus 2 equals 0, so x equals 2. X minus 4 equals 0, so x equals 4. And then y-intercept, you plug it in, you get 0 minus 2, which is -2, times -4 is 8. 8 times -2 is -16. So y-intercept is -16. Vertex point is again at 3, but now you figure out because 2 and 4 is 3, right? But what about the y value? 3 minus 2 is 1. 3 minus 4 is -1. So 1 times -1 is -1. -1 times -2 is +2. So it's at 3,2. Perfect. So I'm just gonna graph it just so that you guys see it. I mean, I think it's really important that you don't have to graph it, but I want to talk about that. Okay. So I know my x-intercept is a 2 and 4, right? I know the vertex point is at 3, -2, which is somewhere around here. Why is it shaking a lot? Okay. And y-intercept is at 16, which is somewhere around here. I'm just gonna connect them so I know it's shaped like this. Make sure it's symmetrical. Okay, just know that it's symmetrical. I didn't know how to graph it, but it's a U shape, right? Looking at this, if I graph this one again, it's a 3, 2. I mean 3 and 2, right? Sorry, I meant 2 and 4. That's your x-intercepts. And then your vertex point is at 3, 2, which is around here, right? So I know, and then y-intercept is -16, so it's around here. So when I connect it, it's shaped like this. Wow, I would say that's a perfect parabola. Oh my god. Oh my god. I could be an artist. Look at that. Alrighty, that's not the point. The point is this. I want to talk about this. What is the difference between these two? It's going to help you answer the next question. You see the difference is this negative outside, right? See, your x-intercepts, it doesn't affect your x-intercepts. It does affect your y value of the vertex point. See how it flips over the x-axis, right? I do want to name it. I can show you. I pulled it up as well on my thing. Look at this, right? As you can see, I'm just going to go down and then it's a perfect symmetrical. I would say so the blue is your negative and your red is the positive. If the leading coefficient is positive, you can clearly see that it's a reflection over the x-axis. Like the red graph was reflected over the x-axis. You see? So if you know how to graph either of them, you know how to graph the other one as well. Just reflect it over the x-axis. Okay? Perfect. So let's answer question number 3 or 4. Is it 4? 4. It is 4. Alrighty. So I know that the x, did any of them remain unchanged? Well, I noticed one thing, that there was a negative leading coefficient. That was the only difference, I would say. Just by looking at the question, right? Coefficient in 3C. Did any of them remain unchanged? Yeah, x-intercepts did not change, right? Did any of them change? Yeah, your y-intercept changed. So did your vertex point. So anything that had the y value, it changed, right? It reflected, right? If it was positive, it became negative. If it was negative, it became positive. If someone were to graph, what would they notice? They would notice that it's reflected over x-axis, right? Like it was this, but then it became this kind of thing. Assume it's perfect reflection, okay? 3a, you're graphing 3a. Well, I'm gonna just get everything here. Your x-intercepts were 3, 1. So I mean 3 and 1. So 3 is here, 1 is here, and then your vertex point is 2, -2, which is around here, and your y-intercept is 0, 6, which is here. I think that's all you need. To be honest, to graph it, all you do is just like connect them. So it's, and we know it's a perfect parabola, right? So like make sure it's I mean, don't make it perfect, but you know it's a perfect parabola. So it's going to draw the line of symmetry where I'm just telling that hey, it's a parabola, it's a perfect parabola. Okay, moving on to question number 6. Question: what values of x maximizes a of x? Right? What are the dimensions of the pan and what is the maximum possible area? To talk about this, okay, let's start from the beginning. Okay, you sometimes will be given polynomial equations and stuff like that, and looking at this is quadratic, right? I know it's quadratic, you know it's quadratic. When you talk about quadratic, what is one thing that there's a point, right? See, here's the thing. If your graph is positive, it's a U shape. You have a minimum, right? If your graph is negative, you have a maximum. How do you find this point? This point is called your vertex point, and we know how to find it, right? Figure out your zeros. You're given zeros here, right? You're given your factors. You got x, and you got 100 minus 2x. So x equals 0 is your first x-intercepts. X equals 50 is your second x-intercepts. To find the maximum possible area, you have to find the center of 0 and 50, which is 25. X equals 25. So when x equals 25, this is your answer, I guess. Like the value of x maximizes your answer. X equals 25 is the maximum volume, right? Its volume, what is it? Fence, I mean fence. Now, so if you plug in 25 here, you get 2500 minus, so 2500 minus 25 squared is 625, I think, and 625 times 2 is 1250. When you subtract this, you get 1250 as well, I would say, right? Yep. How do I check the answer though? I'm gonna graph it. Just give me a moment. I'm gonna graph it. I'm gonna graph it just to make sure. I know I'm right? I know I'm right, but like just to show you as well. 100x minus 2x squared. Interesting. So looking at this, I can see this graph. This is the graph of it. It's a parabola. I'm gonna find the highest value, highest point. I want to find the vertex point. They will give you as well. Oh yeah, I was right. Look at that. 251250. That's the highest point. So all you do is figure out the x-intercepts and find the midpoint, plug it in, figure out the y value. So it's 251250. Perfect. Suppose the length of a garden is x minus 2 and the width is x minus 3. Find an equation that represents the area of the garden and give a reasonable domain. Well, area of a garden would be length times width. Length is x minus 2, width is x minus 3. That's it. That's an equation, right? Equals, we just say area of the garden, area of the garden, A of g. Talking about domain, well, here's my question. When you talk about length, when you talk about width, what does not make sense? What values do not make sense? Personally, for me, I think length cannot be. I mean, you could have a length of 0, but then it's no longer length. If that makes sense. So anything greater than 0 makes sense. Does that make sense? Like 0.1, 0. Anything greater than 0 makes sense to me. So all I do is take this, set it greater than 0, set it as an inequality, add 2 on both the sides. So I know for this scenario x has to be greater than 2 for the domain. For this, x minus 3 is greater than 0, so x has to be greater than 3. So then which one do you pick? X is greater than 2 or x is greater than 3? You always pick the higher one, I guess, because see, if I pick 2, this fails my test. I cannot have that, right? 2 minus 3 is negative 1, width cannot be negative, right? So x has to be greater than 3 because that's the because it works for both of them. 2 doesn't work for this, right? 3 works for both of them, right? For example, what number would be greater than 3? Let's say 4. 4 minus 2 is 2, 4 minus 3 is 1, and it works for both of them, right? Perfect. Moving on. Perfect. They're asking you to expand v of x, this just to like what do I say that? So it's a cubic function. How do I do that? Well, I will pick this one just to like show you. Okay, all you do is create a wall here for now. Okay, let's create a wall. I can do this. This is easy. This is lemon squeezy. Okay, how can I distribute that? I get 30x minus 2x squared. I just distribute the x. Okay, and then I remove this wall. And then I bring this my best friend in, and that's my best friend. 30 minus 2x. Now I FOIL this. 30x minus 30 is 900x. 30x minus 2x is negative 60x squared. Negative 2x squared times 30x is negative 60x squared. Negative 2x squared minus 2x times negative 2x, right, is, yes, I know, 2x squared times 30, that's what I said, right? Perfect. Negative 2x squared times negative 2x is positive 4x cubed. Simplify this again. 900x minus 120x squared plus 4x cubed. If you rewrite this, you go from highest degree, which is 3, so you go 4x cubed minus 120x squared plus 900x, and that will be your answer. That's how we know it's cubic, because the degree is 3. Perfect. Define the domain of x. You know that the cuts must be positive and the box sides must be negative, which makes sense, right? So I'm going to set each factor equal to 0. I'm going to set x greater than 0, not equal to 0, greater than 0. And then 30 minus 2x has to be greater than 0. So 30 has to be greater than 2x, so right? Yeah, less than 30. I forgot. Wait, what? I did 2x, right? So 15. Ooh. Oh yeah, because negative here. Okay. Give me just a second. As long as x is less than 15, we should be okay. Because here we are subtracting x. If you do a higher number, let's say you put 16 here. 16 times 2 is 32. 30 minus 32 is negative 2. You cannot have that. You cannot have a negative, right? So the only thing that makes sense is x has to be less than 15. 14 makes sense, 13 makes sense, and so on and so on. But greater than 0, right? 0, between 0 and 14. Cool. Find the value of x that maximizes the volume and state the volume. Well, to do this, we're gonna have to graph. So I'm gonna graph it. Okay, I'm gonna pull out my calculator again and graph it. So just bear with me for a second. You got x times 30 minus 2x squared. Okay. Ew, this is really bad. Okay. Yep. Perfect. This is like actually really bad. I haven't yet found the graph yet. Imagine the thing. Look, you don't know. So do you see the green thing? That's the graph. It's going so high already. 30 minus 2x, right? Let me see. Yeah, I graphed it correctly. Let me do this again. Let's just do what we did. 4x cubed minus 120 x squared plus 900x. Yep. Okay. Cool. All you do, let's say this in this scenario. I mean, you don't. That's like really hard to answer this question, but oh, yeah. But since x is less than or equal to 15, we could figure it out. But like, let me look at the. Since I know that x is to be greater than, less than 15, so like, I'm just looking for that specific group. How do I? This is so weird. Okay, all you will do is, if when you graph it, here's what's gonna happen, right? You're gonna have like a. Okay, the entire point for this was to talk about this. Let's say that you have this graph, right? This right here is called a relative max. This right here is called relative mean. Okay, what happens is this. Sometimes they ask you this: what value of x minimizes the cost of purchasing or whatever, right? Then you would pick this relative minimum. The reason why it's called relative minimum is because it's within this like neighborhood, I guess. This is at the lowest point, if that makes sense. Even though like there's a lower points within this neighborhood, this is the lowest point. This is relative max because within this neighborhood, yes, there are higher points, but this is the highest point, right? See, it's another way to recognize them. If your graph is increasing, but then suddenly it starts decreasing, that point where it stops to increase, that's relative max. If your graph is decreasing and it starts to increase, that point is relative mean. I should have thought about this before I asked you this question. This was given to me by ChatGPT. Let's be honest about that. But like, like if I were to graph it correctly, I would have like gotten this, and like this would have been my I guess this would have been my answer. I mean, maximum, right? You want to maximize the volume, so I'm looking for something that has the relative max between 0 and 14, because that's where your domain is. So whatever the highest value is between 0 and 14, that should be your answer. Alrighty, that should be it. This is the end of the video. It's 27 minutes. You should be all set. I'll see you all later.